Center. Today, I will present you about limiting and excess. Limiting and excess reactants. Learning objectives. At the end of this lesson, students will be able to understand the concept of limiting and excess reactants, to identify the limiting and excess reactant in a reaction, to use the limiting reactant to do stoichiometric calculations. The concept of limiting and excess reactants. Suppose you are going to eat bread with jelly and peanut butter. Here are the available ingredients. You have 4 slices of bread, 1 jar of peanut butter, and half jar of jelly. Okay, you are going to eat 4 slices of bread with 1 jar of peanut butter and half jar of jelly, in which the limiting reactant is the bread because it is very small. Okay, the excess reactant is peanut butter and jelly, which exists in large amounts. Limiting reactant is a reactant used up in a reaction, consumed in a chemical reaction, completely consumed after completion of what the chemical reaction determines the amount of product. Okay, the amount of the product is calculated by using the given amount of the limiting reactant. Excess reactant is added to ensure that the other reactant is completely used up, and which is cheaper and easier to recycle. Some of these reactants are converted into products. Some of these reactants are left over when the reaction is completed. For example, this is the stoichiometric mixture or stoichiometric proportion, the reaction between nitrogen and hydrogen gas to produce ammonia in the Haber process. Okay, stoichiometrically, 1 mole of nitrogen is combined with 3 mole of hydrogen to produce 2 mole of NH3. In this picture, the light blue color represents hydrogen. The dark blue color represents what? Nitrogen. Okay. Here, the dark blue and light blue colors are what? Joined together. This indicates what? The formation of NH3. Okay. Look at this one. In the pink color circle, there are a dark blue one and 3 light blue ones. Okay. The light blue ones represents what? The 3 mole of hydrogen, and the 1 dark blue represents what? Nitrogen. Okay, reacted in stoichiometric proportion to produce ammonia. Look at this picture. Okay, the next is, look at this, the red and dark blue colors. Okay, before reaction has started, there are what? Red colors and blue colors. The number of blue colors are smaller than what? The number of red colors. Okay, after reaction is completed, all the blue colors are joined together with the red one, but some amount of the red colors are left over after the chemical reaction is what? Completed. This represents what? The blue colors represent the limiting reactant or limiting reagent, and the red colors represents what? The excess reactant or reagent. The limiting reactant or reagent can be determined by 2 methods. Okay, the first one using the mole ratio method, and the second is using the product approach and hiding method. How can we calculate the amount of the product? By using what? 2 given values. One is the limiting amount, the other one is the excess amount. How can we identify from these two given values, the limiting and excess? Can be identified by using this method. The first one, using the mole ratio, and the second is using the product approach or hiding method. Using the mole ratio method, steps in determining limiting reactant. There are what steps? The first step, write and balance the equation for the reaction. Okay, the chemical reaction must be what? Balanced. Second, convert the unknown masses of reactants to moles by using the formula the number of moles equals to the given mass of the substance divided by the molar mass. Molar mass is the mass of 1 mole of a substance. Okay, 1 mole of a substance equals to the molar mass of 1 mole of a substance is equal to the molar mass of 2 mole, 3 mole, and so on. Okay, using the number of the third step, using the number of moles of reactants and the appropriate mole ratios, determine which reactant is limiting. Okay, use the mole ratios of the two reactants, the excess and the limiting, to determine the limiting. Using the amount of limiting reactant and the appropriate mole ratios, compare the number of moles to be to the number of moles of the desired product. Okay, convert from moles of product to grams of product using the molar mass if this is required by the problem. For example, let's see the steps by using what this example. Suppose 316.0 gram of aluminum sulfide reacted with 493.0 gram of water. What mass of the excess reactant remains unreacted? You have an unbalanced chemical reaction. Al2S3 plus H2O produce AlOH3 plus H2O. This is not balanced. First, balance this chemical reaction. This is your first step. Okay. The first step is balance the equation. When we balance this chemical equation, 1 mole of aluminum reacted with 6 mole to produce 2 mole of aluminum hydroxide and 3 mole of H2S. Okay, this is the balanced chemical equation. Then we have to go to the stoichiometric calculation. Next, determine moles, then limiting reagent. Okay, first determine the number of moles of each of the reactants. Okay, by using what the two given values. You have given mole of aluminum sulfide and given mole of water. Then calculate the number of mole. Number of mole calculated by the formula equals to what? Given mass divided by molar mass. Okay, therefore mole of aluminum sulfide equals to 316.0 gram divided by 150.2 gram per mole. Okay, 150.2 gram per mole is the molar mass of Al2S3, because the mass of aluminum is 27, which is multiplied by 2 is 54. The mass of sulfur is 32. 32 multiplied by 3 is 96. 96 plus 54 is equals to 150 gram per mole. And the mole ratio gives what? 2.1 mole. Okay, 360 divided by 150 is 2.1 mole. Okay, and the mole of water equals to 493.0 gram divided by 18 gram per mole, which equals to 27.4 mole of what? Water. 18 gram is obtained from the sum of the mass of hydrogen and oxygen in H2O. Okay, 2 times the mass of hydrogen is 1. The mass of one oxygen atom is 16. 1 times 16 plus 2 times 1 is 18 gram. 493 divided by 18 is 27.4 mole. Then calculate the mole ratio. The mole ratio of Al2S3 and H2O. Mole ratio of Al2S3 is 2.1 divided by what? 1. 1 is the coefficient of Al2S3. Okay, after balancing this chemical equation, the number of moles of Al2S3 is 1 mole from the stoichiometry proportion. 2.1 divided by 1 is 2.1. The mole ratio of water is 27.4 divided by 6. 6 is the coefficient of H2O. This gives 4.6. And then compare and contrast the two results, the two mass ratios of Al2S3 and H2O. Which one is greater, which one is smaller? 2.1 is the smaller one, and 4.6 is the bigger one. The bigger one indicates H2O is the excess reactant, and the smaller one, 2.1, indicates what? Al2S3 is the limiting reactant. Then determine the amount of determine grams of water that reacted with 316.0 gram. Okay, so all these 316.0 gram of Al2S3 is converted into product, but all the given amount of H2O is not converted into the product. Some amount converted into the product, some amount left over, because H2O is the excess reactant, Al2S3 is the limiting reactant. Then the amount of H2O reacted is calculated by using this method. Okay, 316 gram over what? 150 gram. This is the mass of aluminum sulfide from the stoichiometry proportion, which equals to X over 180 gram. This is the mass of water from the balanced chemical equation. And this gives X equals to 316 multiplied by 108 divided by 150. This gives 227.52 gram of water reacted. Okay. The next is determine the unreacted amount of the excess reactant. The unreacted amount of water, that means total given mass of H2O is 493 gram. The reacted mass of H2O is calculated as what? 227.52 gram of water. The total given mass of H2O is equal to reacted amount plus unreacted, and the unreacted amount equals total mass of H2O divided by reacted amount of water, which equals to 493 minus 227.5. This gives 265.5 gram of H2O is remain unreacted, left over after the chemical reaction is complete. Okay, the second method using the product approach or hiding method, in which you can calculate the amount of product by using the two given amount of the reactants by hiding one of the givens and vice versa. You may use the mole ratios or mass ratios and compare the amount of product each reactant will produce. Okay, you'll calculate the amount of product by using what the two given mass of the limiting and excess reactants. These are what the steps. First, balance the chemical equation. In all stoichiometry calculation, the chemical reaction must be what? Balanced. Convert the given information into moles. Use stoichiometry for each individual reactant to find the mass of product produced. And the reactant that produce a lesser amount of product is the limiting reactant or limiting reagent. The reactant that produces a larger amount of product is the excess reagent. To find the amount of remaining excess reactant, subtract the mass of the excess reagent consumed from the mass of what the excess reagent given. Example, potassium superoxide, KO2, is used in repressing gas masks to generate oxygen. Okay, source of oxygen. Okay, potassium superoxide is used as source of oxygen, usually in hospitals and submarines. Spacecraft use potassium superoxide as a source of what? Oxygen. Examples: potassium superoxide, KO2, is used in replacing gas masks to generate oxygen. 4KO2 plus 2H2O produce 4KOH plus 3O2. How many moles of O2 can be produced from 0.15 mole of KO2? You have given values, given mole of what? KO2, and you are asked to find the number of moles of what? O2, the products, okay? O2 is a product. You are asked to find the number of moles of O2 by using what? The two given masses, 0.1415 mole of K2, the reactant, and 0.10 mole of H2O, okay? Then how can you find the amount of the product oxygen by using these two given masses? First, identify, write the balanced chemical equation. It is 4KO2 plus 2H2O gives 4KOH plus 3O2. Then identify the given and required. You have two given number of moles, 0.15 mole of KO2 and 0.10 mole of H2O. And you are asked to find the number of moles of what? Oxygen, X, which is represented by what? The letter X. Then okay, after you identify the given and required, then find out the number of moles from the balanced chemical equation. That means the coefficient of KO2 is 4. From the balanced chemical equation, KO2 is what? 4 mole. The number of moles of H2O is 2 mole. The number of moles of O2 is 3 mole. Okay, then we are using the second method, which is the product approach method or the hiding method. Let's first hide the given mole, 0.1 mole of what? H2O, okay? Hide it, then calculate the amount of the product by using the given amount of KO2, 0.15 mole, and find X, okay? From the balanced chemical equation, you have 4 mole KO2 will produce what? 3 mole of O2. 0.15 mole over 4 mole equals X over 3 mole. This gives 0.15 mole times what? 3 mole over 4 mole. Mole is cancelled by mole, and this gives 0.11 mole. In the second step, hide 0.15 mole, okay? You have to hide 0.15 mole, which is the given amount of O2, and then calculate the amount of the product O2 by using 0.10 mole, okay? 0.10 mole over 2 mole equals to X over 3 mole. This gives X equals to 0.10 times 3 divided by 2, which equals to 0.15 mole. And then the next step, compare the two amount of the products, 0.1 mole and 0.15 mole. Which one is bigger? 0.15 mole is bigger than 0.11 mole. This 0.11 mole, the smaller number, indicates what? Potassium superoxide is the limiting reactant, and the bigger number, 0.15 mole, represents H2O is the limiting reactant. And the amount of O2 is determined by the amount of the product KO2, which equals to 0.11 mole. The next example, 100 gram of hydrochloric acid is added to 100 gram of zinc. Find the volume of hydrogen gas involved with standard laboratory conditions. Solution: atomic mass of hydrogen is 1, atomic mass of fluorine is 35.5, the atomic mass of zinc is 65. The chemical equation for this reaction is given below. 100 gram, the given mass of hydrochloric acid. Here you have 100 gram of hydrochloric acid added to 100 gram of what? Zinc. Okay, the mass of zinc and hydrochloric acid is the same. It is 100 gram, 100 gram. And the required one is the number of, the volume of what? Hydrogen in liter, X. Then find this X. First, hide the given mass of zinc, that set and find the amount of X by using what? The given mass of hydrochloric acid. And the second step, hide the given mass of hydrochloric acid and find the amount X in volume by using what? The given mass of zinc. And the third step is compare and contrast the two amounts of what? Hydrogen, the two volumes of hydrogen. The smaller one indicates what? The amount of hydrogen, and indicates the limiting reactant. Okay, let's go to the discussion. First, hide the given 100 gram of what? Zinc. Okay, 100 gram of zinc is hidden here, and calculate the volume of hydrogen in liter by using the 100 gram of hydrochloric acid. Okay, 100 gram hydrochloric acid divided by 73 gram of hydrochloric acid, which equals to X over 1 times 22.4 liter, which is 22.4 liter, and then crisscross. X equals 100 gram times 22.4 liter divided by 73. This gives X equals to 30.7 liter of hydrogen gas. And then the second, hide the given 100 gram of HCl, hide the given, hide the given mass of hydrochloric acid. Okay, hide this one and find the mass of hydrogen gas by using the given mass of zinc. Okay, the given mass of zinc is 100 gram divided by what? 65 gram, 65 gram, which equals to X over 24 gram. This gives 34.5 liter of hydrogen gas. And then compare these two volumes of hydrogen. Okay, this one is 30.7, which is smaller than 34.5 gram. The smaller one indicates HCl is a limiting reactant, which determines the amount of the product. And that means the amount of the product is calculated by using the given mass, 100 gram of HCl. And the bigger number, 34.5 liter of hydrogen, represents what? Zinc is the excess reactant, in which some amount of zinc is converted into product, some amount of zinc is left over at the end of what? The reaction. Therefore, the volume of hydrogen is 30.7 liter of H2. Okay, this is all about limiting and excess reactant. Let's summarize the main points. Limiting reactant used up in a reaction, consumed in a reaction. We assume that the limiting reactant is 100% converted into what product? The excess reactant, some of this reactant left over when the reaction is what? Completed. Okay. This is enough for limiting and excess reactants. Thank you for watching. See you later.